So greetings from CSR Nest, Jorat, Assam, India. Good morning, one and all. This is day 5 of what has been an intriguing journey of knowledge sharing and integration from finest mind of the world, with an average attendance of 800 participants per lecture in MS Team platform, excluding participation via YouTube and Facebook live stream. IVWGST 2020 is received warmly by the global audience. I welcome each and every participant to today's lecture. The keynote speaker for which is Professor Ramesh Singh from Chapman University, USA. The title of his lecture is Ground, Borehole and Satellite Observations for Search of Reliable Earthquake Precursors. If you could not attend the previous lectures, the entire lecture session have been recorded and uploaded in the official YouTube channel of our institute, that is CSR SRTP. The link of each of the lectures is typically shared in WhatsApp as well as in Telegram groups. Now may I request Professor J.R. Kyle, the session chairperson, to say a few words before starting the session. Over to Professor Kyle.
Thank you, Santanu. I think it's a great day for us to have Professor Ramesh Singh with us. And good morning to Professor Singh and all participants today who have joined with us. It's a very important topic in seismology because seismologists are struggling to understand precursors. And Northeast India being a field laboratory, we did some work in the past, and now a permanent observatory has been established in Northeast India under NIST. The observatory is in Tejpur. So I think Professor Singh's lecture would be of much beneficial to all of us, particularly who are in this research of precursors for earthquakes. I think we are still in the understanding process, but this type of precursors like ground precursors, borehole precursors, and from satellite precursors, all in one platform, I think that will be a wonderful lecture by Professor Singh, and we all look forward to hearing you, Professor Singh. Now over to Shantanu.
Now may I request our co-session chairperson, Dr. Saurabh Barua, for his initial remarks. Over to Dr. Saurabh Barua.
Yeah, good morning, everyone. Good evening, everyone from this part of the world. It's really overwhelming lectures that we have heard from different laureates in earthquake seismology. Today, here with us, Professor Ramesh P. Singh from Chapman University with a very important topic, as already said by Professor J.R. Kyle, that is on earthquake precursor signatures. Earthquake precursor signatures that has started right from Charles Richter, and it has been tried throughout the world, and a lot of money has been invested on this issue to answer these particular questions of forecasting earthquakes or predicting earthquakes, whatever we say. In that regard, this particular topic really will be enchanting to us because Northeast Institute of Science and Technology over the last 5 years, under the sponsorship of Ministry of Arts Sciences, New Delhi, has established one multi-parametric geophysical observatory where 9 geophysical instruments simultaneously running to look after the precursory signatures in that particular stress region near Himalaya and Bhutan border, that is called Tejpur. It is highly stressed zone and it's an open laboratory. So this particular topic, ground, borehole, satellite observations, really will be a pathfinder to our endeavor in this part of the world. Thank you so much. Over to Dr. Santanu Boru.
So thank you very much for your remarks. Now may I read out a summarized biodata of Professor Singh. Professor Singh is presently serving as professor at Chapman University, USA. His prime expertise includes natural hazards, early warning of coastal earthquakes, soil moisture, landslide, snow avalanches, floods, dust storms, remote sensing applications, geophysical explorations, atmospheric pollution, and mining environment, amongst other. Prior to his present engagement, he has served as professor at George Mason University, USA, and at IIT Kanpur, India. He pursued his bachelor's, master's, and PhD from the prestigious Banaras Hindu University, India. Professor Singh has authored more than 110 research publications. He is the chief editor of Geometrics, Natural Hazards, and Risks, published by Taylor and Francis, UK, and was one for the Journal of the Indian Society of Remote Sensing. He has served as editorial board of the Journal of Terrestrial Observations, International Journal of Remote Sensing, Indian Journal of Marine Science, Disaster, etc. Professor Singh was awarded with National Mineral Award by Department of Steel and Mines, Government of India, New Delhi, in the year 1991. He was also the recipient of Indian National Remote Sensing Award in 1996 and Hari Om Ashram Merit Award in 1997. So this was a very brief and concise introduction of Professor Singh. Thank you, Professor, for accepting our request to be one of the keynote speakers. I take extreme pride in learning about your Indian lineage. This time is all yours now. Thank you, Professor. Now over to you.
Good morning to all those who are in India. Greetings from Orange County, California. You can see my university. Okay. So first of all, I thank Dr. Barua, the chief scientist, Dr. Barua, coordinator, Dr. Kayal, for inviting me for this talk. And I don't think I'm so much expert on this, but I will try, because ever since I was a student. First of all, let me come to your office. Okay. Wait a minute. Sorry. Okay. So I believe this is your institute, right? And I'm wondering why the roof is red. Okay. Maybe I will discuss with you. Okay, and this is I saw Google Earth image since I'm also a remote sensing person, so I inserted this. So virtually, I'm coming to your office. Okay, and thanks to everybody. And you say that the earthquakes are bound to occur. One cannot stop. Okay. And you people are sitting in a very vulnerable region, Assam, and the earthquake prediction forecast. Yesterday, Nicholas, he gave a lecture and he was talking about the aftershocks. And ever since I know I was a graduate student, we were talking about the earthquake predictions, okay? And the earthquake prediction is not possible so far, but some of the pseudoscientists forecast earthquakes, okay? So earthquake prediction, no one can predict earthquake. But some group of scientists do believe that they will be able to predict the earthquake. And about 20 years back, I witnessed one meeting in Japan. all the audience, they were fighting, you see, and one group says, oh, we can predict earthquake, and the other group says, no. So there was a big fight. And earthquake prediction is a very controversial topic. And when I was doing my graduate studies at the Banaras Hindu University, and I was listening to so many great Indian scientists, and they were doing all kinds of measurements in Assam. And even the GSI were doing some field measurements, and then they did the geoelectrical sounding, electrical, magnetic anomaly measurements, all sorts of VP, VS ratios, everything. Okay. So for the earthquake prediction, I want to show that every time we are getting so many warning from the pseudoscientists, okay, this from a Gmail, from the other parts of India and other countries, we get a lot of warning, okay, and they claim that we can predict earthquake, but don't believe that. Okay, so I'm going to talk about Indian context, okay. And you see, we have to understand the geology of India, and the geology of India, you can see, made up of different cratons. This is the Indo-Gangetic plain, and you can see the earthquake zoning map, and the earthquake occurred all over India. And what I'm saying, that the earthquakes are occurring at plate boundaries. Everybody knows these are the interplate earthquakes. But the earthquakes occurring here are intraplate earthquakes. The physics of intraplate earthquakes we have not been able to understand so far. Okay. And then when I was at IIT Kanpur for 23 years, I was even I deployed the GPS station, okay, and on campaign mode, and one permanent GPS station in Kanpur, we were trying to do this measurements there. So first of all, we should know about the tectonics, about the geology of India. This is very, very important, because if we understand the earthquake processes, then only we can understand, we should try to understand the precursors, okay? So here, like you can see the geotectonics, and you can see about in the month of March, April, people were observing earthquakes in Delhi, and about 10, 11 earthquakes we observed. Magnitude 3.5, 2.5, 3 like this, and since it happened during the COVID-19 pandemic, and at that time the people, they felt the earthquake shaking up to large distances. Okay. And I'm happy that the people from the ministry, National Institute of Seismology, they have now published a few papers related with those earthquakes. And I also put a note in Tumblr magazine about one event, why we have observed the shaking for the larger distances. I'm very happy that in India there are the GPS stations, which is very, very important. GPS are located in the Himalayan region, GPS are located on the Shield region. Why? Because see, we are sitting very close to the Himalayan belt, and in the past there were the large number of earthquakes, and we are expecting that the big earthquakes are due, like I mean, in the Himalayan region, similar to this in California also. Okay. And I was told that she will be talking tomorrow morning. She might cover this. Okay. So when I was doing my postdoc at the University of Alberta, okay, at that time I was doing this finite element modeling, and then we published this paper, lithospheric deformation beneath the Himalayan region, and then I started learning about the convection cells and about the compressional tensional forces. Okay, so this paper we wrote in 1990 based on the numerical modeling, the finite element modeling at that time. You see, okay. So everybody knows the Indian plate is moving, and Assam is moving at the I believe 50 to 20 millimeter per year. Otherwise, on an average, Indian plate is the 5 to 6 millimeter per year. Okay, so earthquakes is a very complex, and it occurs in the complex Earth with a varying geology, tectonics, and different rocks, geophysical structures, varying focal depth, different types of fault, varying hydrological environment. Okay. And the earthquakes have no liking or disliking, can occur in the night or daytime. Okay, you cannot stop, as I said that. Okay, so precursor studies, as I told you, even when I was a graduate students, I started hearing about the precursors. GSI was doing a lot of work, and today I was sitting and I was searching for some of the papers on the Web of Science. Maybe they published in the Indian journal, so those are not listed. So 75 to 85, Assam was considered as an active region. It may be still, but where GSI scientists were looking all kind of earthquake precursor to get an early earthquake signal. Indian scientists made efforts and spent money, as Dr. Burgos said in the beginning. They made a lot of spent a lot of money. They were looking for the precursor at the northeastern region. There are few papers they published in Tectonophysics and the Geological Survey of India. They observed positive and negative anomalies of numerous geophysical parameters. Okay, if they find something electrical resistivity, they say, oh, 40% the resistivity anomaly they are getting, just like this. Okay, and the great Indian geophysicist giving warning about an impending earthquake on the basis of that, but no luck. Okay, because the earthquake prediction is very, very difficult. So it was set back to me, and I lost my trust on Indian great scientists. Okay, so that is the story in the beginning. So the earthquake predictions, what you're seeing, people they try to do the earthquake prediction, long time predictions, medium-term predictions, and the short-time predictions. They are looking for so many types of anomalies. Okay, like seismicity patterns, foreshocks, electronic fields, radon or hydrogen gas content of soil or groundwater, water levels in wells, animal behavior. seismic wave velocity changes. So these are the parameters people are talking since more than 40 years, as far as I know. Okay, but there's no luck on the basis of these parameters. They come to the media that, hey, the earthquake is going to come. I remember one time when I was at IIT Kanpur, somebody projected that tomorrow there will be earthquake at 8 o'clock. It came on the national TV, and the guy was from Tamil Nadu, okay, and there was no earthquake, and the guy was kept behind the bar. Okay, so one should be very careful. Okay, we have to learn things. We should not go to the media in the name of earthquake prediction. Okay, I want to warn everybody. Okay, so try to understand this. Earthquake occurs at a 4-kilometer depth or beneath that. And this is a sketch. What I'm saying that there is a crustal movement, electronic precursors. People, they see this seismic activities and the changes in the water table, water temperature, radon concentration. And then we started talking about the ionospheric fluctuations. Okay, on the ground, you can measure the electrical resistivity anomaly, electromagnetic anomalies, the borehole anomalies, such anomalies, and then the French people, they launch a satellite, D-meter satellite, and then there is the magnetic satellite launched by Norway, and then there is a Chinese satellite right now in the orbit, and they are trying to find out the change in the parameters related with the earthquake and volcanic emission. Okay, but and at that we are talking since the last 1 decade about the total electron content. Okay, and this looks to be one of the potential precursor. Okay. And I know there is a group at JPL, they are also doing this, and then there is a group in Japan, in China. The people are trying to do this from tech precursor, the total electron content. And if you have a good network of GPS provides you cluster motion, provides you information about the water vapor, provides information about the total electron content. Okay, and there is Professor Heike is there in Hokkaido University, and he writes a very good paper in GRL and JGR. Okay, and there are different groups. They claim that the tech anomaly. It can work as a good precursor. Okay, so possible causes of tech, total electron content. This could be related with the geochemical processes in the dilatant phase of earthquake preparation, such as the radon ionization causing long-living ion clusters in the lower atmosphere. The question is, this is not only the one cause. There could be so many causes. Okay, and one should be careful. Okay, activation of highly mobile electronic charge carriers and rocks near the Earth's surface. It could be release of CO2 gas, which could potentially destroy neutral clusters, resulting in the near ground layer becoming rich in ions. Okay. The resultant lower atmosphere electric field follows geomagnetic field lines into the ionosphere, leading to the noted anomalies. The question is, The earthquake occurs in a different environment, geological environment, tectonic environment. And if one sees some tech anomaly, some anomaly, it doesn't mean that you will always see at other places. Okay. So always yesterday we were talking about the park field, and people there are the giant U.S. scientists. If somebody finds some anomaly somewhere else, they say, no, it doesn't. We cannot believe, because they consider Parkfield as a very good lab, you see. So there is always a problem, you see. So I believe that the tectonic environment, hydrological settings are quite different from place to place. And one should try to understand at a different region, and also the focal mechanisms are different for a different earthquakes. So the focal mechanism also affect the earthquake understanding. Okay. Here is the tech anomaly 5 days before Sumatra earthquake. You can see here, this is what the anomaly people talked about this. And this was published by Tiger Liu in 2011, okay? And the people also published the tech anomaly, okay? So this is a Chinese satellite, the launched by China, and the basic principle you can see what you say, that there is the stress buildup. Whenever there is stress buildup, there is the emission of the seismic waves, there is the emission of electromagnetic waves, there is the also disturbance of the gases and the water level, all this. And here the Chinese, they are saying that we can measure the ionospheric anomaly. Okay, so far this is about 1 year back they launched a satellite. So I'm not seeing any result, but people are very much expecting that they might find some clue. Okay, so seismo-electromagnetic community believes changes on Earth, atmosphere, meteorological, and atmospheric parameter. And what I like, that the earthquake occurs 4 kilometers deep and below. So whenever something happens 4 kilometers below, then it affects the shallow region. It affects the ground surface, it affects the lower atmosphere, it affects the ionosphere. Okay, so now we believe that there is a coupling between the land, atmosphere, and also ionosphere. This coupling is very, very important. Okay, and that coupling depends on so many factors. Okay. So one has to understand this before one should say that hey, these signals can be used for as an alert for the earthquake. Okay, this is very, very complex and important. So now question is, can we observe signal of an earthquake occurred on the land or an ocean? Earthquake occurred on the land, also earthquake occurred in the ocean. Okay, so, but the question is how we can observe the signals. Okay, through measurements on the surface, borehole, atmosphere, and ionosphere. Okay, yes. Do we have a tool? Yes, now we have a tool. And we can deploy this on the surface, we can deploy in the borehole we can see the atmosphere, and also with the GPS, we can see the ionospheric changes. Okay. So I was looking the paper today, and I saw that this paper, investigation on the aftershock sequence of a great Assam earthquake of August 15th, 1950. Okay. And it is co-authored by late Dr. Chauhan, Professor V.K. Gaud, and late Professor Jagdev Singh, who was a professor at ISM. I'm sure Professor Kayal is there. He must have he must be his teacher, and he also came to Benares, so I met him. Okay, so you can see the aftershocks. In the study we were talking about the aftershocks. Okay, so you can see from August 15th to August 23rd, 1950, there were so many aftershocks when the big earthquake occurs here. And now USGS, we came to know that they had a model to calculate the, to know the aftershocks. Okay, so one thing is just today I read this paper by Gupta et al. In 2015, not Gupta from Assam, published in Tectonics. And then another paper I read, Deva Chandra et al. 2014. And of course, you can see the GPS, you can see the vector. GPS vector, and here the Assam, when I was a graduate student, I understood that there are forces acting from different sides, because Assam is located in a triangular position. Okay, so one direction is this direction, other direction is from there on the opposite direction, and then you can see all the stress field there. So Assam is very, very important. Okay. Okay. So one thing I want to tell you that you see Coachella Valley Preserve. This is 500 miles from San Francisco. From my place here, about 100 miles, I believe, less than 100 miles. When the 1906 San Francisco earthquake occurred, at 500 miles, there was a water oozed there, and in the desert. And the water, when it oozed, and now you can see the forest. And at this point, I want to show you is the far away. This is close to the Palm Springs, about 25 miles. And you can see in a very small place, there are trees came, okay, and here inside this, the water oozed. So it was very interesting for me to see this. And you can see around this. So what I'm trying to say, that 1906, the earthquake occurred in San Francisco, but the effect was seen about 500 miles far away. Okay, so like when the earthquake occurred in Gujarat, we felt shaking sitting in IIT Kanpur in my house 425 there, you see. And then this one is this place, you can see, because there is I took this photograph, and there is a fault system, and this is why water oozed there. You can see the fault, and the water is there, and now USGS has put a borehole to observe the water level. Okay, so like I'm talking about the ground observation, I'm talking about the borehole observation, I'm talking about the satellite observation. Satellite, I have contributed so much in the remote sensing, okay, since I was a graduate student. And then at IIT Kanpur, I started using the optical remote sensing, microwave remote sensing, and now we use hyperspectral remote sensing. Okay, the remote sensing is done with a shorter wavelength and the longer wavelength. I have also used the longer wavelength. Like I was going beneath a 200-kilometer in India, 200-kilometer deep. And I did about 150 magnetotelluric soundings. I claim that I understand the tectonic formation in the Indo-Gangetic Plain, and also in the central part of India, and also along the Cambay Basin. I did in collaboration with the Oil and Natural Gas Commission and the DNES. Okay, so the satellite, now we have multi-sensor data, and which are capable in providing information about the land cover, ocean, atmosphere, the cryosphere, that is the cryosphere is the snow glaciers, okay, and meteorological parameters, okay. Meteorological parameters, you get information about the relative humidity, you get information about the water vapor, you get information about the air temperature. All these parameters now we know. So information about some of these parameters are available at a different pressure levels and at a different heights. Anybody, if you are interested, you can contact me and I will tell you, sitting before your laptop or desktop, you can download data freely, because these are from NASA satellites, not from Indian satellite. The Indian satellite, when I was at IIT Kanpur, I was making a lot of noise to get them free data, and it was very, very difficult. But the ISRO people, they made me happy to give some free data. Okay. But what is the strength of the remote sensing? You can see the San Andreas fault, and from the remote sensing image, and if you move there, if you are not a good structural geologist, you will not identify the San Andreas fault. But the remote sensing image, you can identify this. Similar to this, you see the image here, Yamuna Tier fault, then Ganga Tier fault, okay? And there also, if you go there, you cannot identify that you are sitting in the fault. But from the remote sensing image, you can identify that this is Ganga Tier fault, this is Yamuna Tier fault, and then you can map the lineaments, okay? And the lineaments is like a fracture zones, and the faults or the fractures are the potential zones for the earthquakes. Okay, so that helps you to understand the vulnerability of any region. Okay, so as I listed, people they started talking about the animal behavior. And when I joined Chapman University in 2009, because I'm in the Smith College of Science and Technology, and my colleagues are from the biology, and they were dealing with the animals, the mice. I say, hey, let me also set up this experiments. And we are sitting in an earthquake-prone region, and where the earthquakes of magnitude 2.5, 3.5 occurred, close to Chapman. And then I was very excited. And I spent my money. I put 8 wheel and 8 mice. You see this? And I'm thinking that let's see if we can find the animal behavior. Okay. And you will be surprised that when I saw that the data for the 5, 6, 7 months, and the data came, and I was very much excited. Okay. But when I put the video, okay, digital camera, then I saw that these mice, they are cheating us. And how they are cheating? Because they got a wheel and then they started doing exercise. Okay. And then we figured it out, and then we put all the data in the West basket. I said, "There's no way I'm going to believe there's one." Okay. Now when the Uttarkashi earthquake occurred, I was in the field, and the people, they were talking about the dogs were barking, cats were jumping like this. But now there are people, they publish papers, and I don't believe them. Scientists are very greedy for publications. Okay, but we should do it with honest. Okay, and if we find such things in our data, we should not try to use it. Okay, so I will not encourage anybody to see this animal behavior. Okay, and this cannot be used for the earthquake predictions. Okay, okay, so this I told you about this. Okay, let me tell you the way back 1984. Okay, because I was doing dielectric measurements, electrical properties measurements during my PhD. Okay, and also I got a postdoc at the University of Alberta to do these measurements, very high frequency measurements and the microwave measurements. Then I saw that the dielectric properties is very sensitive to the water. And then I proposed this, and we published this paper in Geophysical Prospecting, that the application of very high frequency measurements to earthquake prediction. Okay, so and I'm very happy that Dr. Khatri was at that time. Okay, he encouraged me. He liked this idea. Okay, so do we have a reliable earthquake precursors? The answer is no. Okay, so we have to understand the precursor. As Dr. Barua said, we have to understand this, and I'm very happy that he has a multi-parameters monitoring systems for the prediction, for the forecasting, for the earthquake precursor. That's a very good thing. Okay, so let me start with talking about the Gujarat earthquake of January 26, 2001. Okay, at that time I was on the IIT Kanpur campus. The moment it occurred, I was watching the TV. I was seeing the Independence Day celebration. Earthquake occurred 8:45, and immediately I felt a jerk. I sent out a mail to all the faculty members that there is an earthquake, and based on the motion, I said this earthquake must have been the south of India. Okay, because the shaking was very intense, But if the shaking, if the earthquake occurs in the Himalaya, shaking will be less there because of the Indo-Gangetic plain. Okay, so here you can see the earthquake occurred here in Bhuj, and then now you can see the Gujarat earthquake. Okay, and Bhuj, whole village was collapsed. You can see the cracks on the buildings. You can see this building tilted. Okay, and then I started thinking why this building is tilted, intact, some building is collapsing. I started thinking about that. Okay. Dr. Barua, is there any problem? Everything is okay?
Everything is okay.
Okay, very good. Okay.
Yeah.
So this is the thing, and immediately I took 10 people. And then we spent about 1 month in Ahmedabad, and we did a lot of work. And I was joined by 3 Japanese scientists came, and then you can see I got some assistance from the co-op there. We were sleeping in the tent. And I did the electrical resistivity soundings also to see what is the depth of the water table. That is a very important parameters. Okay, important parameters because we make buildings. Okay, without the knowledge of the groundwater table, but whenever in the earthquake environment, if there is the shallow water, and then of course you talk about the liquefaction, and at that time some buildings are going to collapse, but the water table is deeper, and then only the buildings are such buildings you see this. Okay, and this is why we did the electrical resistivity soundings, and this we published in Geological Survey of India at that time. And then at that time, whatever like resources I had, I started analyzing all kinds of remote sensing data. And this remote sensing data, we started looking for the water vapor anomaly. Okay, right for January 1-2 days before that, we saw the anomaly. And this anomaly was a very, very important in the sense now we have INSAR. Okay. And whenever there is a water vapor, INSAR is not going to work. Okay, this was our conclusion, and we published in this paper about the water vapor. And now NICER and NASA, the ISRO and NASA is going to launch a satellite thing in the 2022, I believe, and that is going to be INSAR, providing INSAR image, which can be used for the subsidence studies. It can be used for the earthquake study. Okay. At that time also, people started looking for the Moody's infrared thermal images, okay, and they found them anomalies. And this paper was written by Demeter Ozno and Freon from JPL, okay, and they found the anomaly. But the question is whether such anomaly is a reliable anomaly. And that is a big question. Okay. And let me talk about the hydrological oozing of gas response associated with the earthquake. Okay. This image is also from Gujarat. Okay. And This looks like a mud volcano, but this photograph I took this in the field at that time, and then I talked to the villagers at that time. When this earthquake occurred, and the water came as a fountain up to 30 meters or so. Okay, and this is why you can see it looks like a crater. Okay, and water came because the environment is a marine environment, and you can see the salt water. The white one is salt water. Okay. Okay, so here is, I'm trying to show you the brightness temperature. Brightness temperature is the parameter which you get from the passive microwave data. The satellite remote sensing is done with the optical remote sensing and the passive microwave. And the beauty of the microwave remote sensing has some penetration inside the earth, about 5 to 6 centimeters. Okay. But the optical, as soon as it touches the surface, it is reflected back. It does not give you any depth information. Only in case of snow, in case of water, it provides some information. Otherwise, no. So here is the brightness temperature. And these sensors, what we used, and of course, the Indian sensors, and that was 85 gigahertz, and it was a multi-frequency sensor. And this I'm trying to show you the brightness temperature. Okay, how the brightness temperature varies, and this was like a dotted one is the earthquake date, and before that you see some anomalies. Such anomalies we noted down, and this we published this paper in applied geochemistry in 2010. And what we found a peculiar characteristic shape of the brightness temperature. This, try to see that one. Okay, rise in TB before the event. And this is what we found as such characteristic. And now the people use such data they have found for the other earthquakes. Okay, and then at the same time we did this one other parameters we took, and this parameter the surface latent heat flux, and at that time we found some anomaly. And when I found the anomaly, I published that one, and I claimed that, hey, this can be used as an earthquake precursor. But at the same time, I published this paper in NHESS, but at the same time, I submitted this paper in Geophysical Research Letter, and the reviewers, because this was only for 2 months data, and the reviewer sent me the whole data for 1 year. Okay, and then he said, okay, now you can identify the anomaly, whether it is when you are getting the anomaly for a whole year, do you think that the earthquake can occur whenever you see the anomaly? Okay, and later on, we did a lot of studies related with the surface latent heat flux. Okay, and then we enhanced our understanding why such anomalies, and then we found that such anomaly can be also associated with the monsoon. Such anomaly could be. Hello? Such anomaly could be due to other disturbances. Okay, so I tried to analyze about the 40 earthquake data. I submitted there to the, at that time in Nature, and I employed the 10, 12 students from the IIT Kanpur, okay, that Nature encouraged me. And then when I analyzed so many earthquake data, then I said, no way, you are going to get such an anomaly everywhere. You see? And then I dropped this idea. Okay, so that is the story about the surface latent heat flux. Okay, so otherwise you can see the surface latent heat flux. When you see in a small window, you'll find the anomalous surface latent heat flux. But here, when we took data for a whole year, then you are getting a peak, more than 2 standard sigma, you see. And now the question is whether this anomaly, it is giving some information about the earthquake. The answer is no. Okay. So so you can publish a paper. There are so many journals coming. You can publish that one thing, but I will not encourage you people. Okay, I will encourage you that we should try to see what is happening to other parameters. And the same thing here for the SLHF for Sumatra for December 2004 to June 2005. And we got a very good results. This was the cover page of the International Journal of Remote Sensing. We published this one. Okay, so it looks very nice anomaly. Okay, but whether you are going to get an anomaly, whether it is going to get some information, reliable information, that is a big problem. Okay, so the surface latent heat flux was introduced by us in 2003, and it seems to contain precursory information for the larger earthquake. Look, I started dealing with that, but the Chinese people, oh God, whenever earthquake occurs, they try to see such an anomaly, the surface latent heat flux. They publish this, okay, and so if you see any one parameter, you may find an anomaly, but that anomaly is just by fluke, okay, and you cannot get any other information, and no seismologist is going to believe you. Okay. Okay. So this was, I was talking about the carbon monoxide total column A in Gujarat. The Gujarat one earthquake is the one earthquake which is well studied. The people, they have studied all kinds of parameters on the ground, in the atmosphere, and also using the satellite remote sensing. Okay, and you can see we published this paper, satellite detection of carbon monoxide, okay, emission prior to the Gujarat earthquake. This is a good journal, Applied Geochemistry, okay, but I will tell you the story later on, okay. So here is the carbon monoxide for the Nepal Gorkha earthquake, okay, and we saw some anomalies, okay, related with the two earthquake. This is what I'm trying to show you, okay. Here we found the anomaly at the different pressure level, okay, and this data, the AIRS, the name of the satellite is AIRS, and this provides the information at a different pressure level, different altitude, okay. So we found anomaly, and this paper we have published this in one of the journals. Here I want to tell you the story. The story is this, that people, they saw in the image the carbon monoxide on the west coast of the United States. See this? Okay. And this, and the people they started looking at Google, and they found my work published in the Applied Geochemistry about the carbon monoxide. And then they put on the website, and I got about, when I was sleeping, I was in the bed, I got a phone call, and then people, they say, hey, your name appeared here, there. By the evening, I got about 100 emails. Okay. When I got 100 emails, I said, whoa, what is going on? You see, okay. And then by the evening, the whole news spread over. I started getting phone call from the New Orleans, Boulder, Colorado, that, hey, big earthquake is going to come, and what do you think? Can I ask my daughter? Can I ask my son or family to evacuate the area? I said, hey, this is all I don't believe this. Okay. So I want to tell you that this was the NASA satellite image is sparks fears for the big earthquake, which is hit the LA, but the space agency says it was just a technical glitch. Okay. So later on, and the news media contacted the USGS, but you see, nobody came to answer this, okay? Because the government, if you are working in the government team, you have to shut your mouth, okay? You cannot talk to the media. Otherwise, people, they suffered in the Italy, and this is what the big danger. So so you can see the CBS News came to my office, took my interview, okay, in my office, and then I said, no, little knowledge is always dangerous, okay. So, and then later on, we came to know that this was a glitch, and this glitch created a lot of confusion. And this is what I'm trying to say, that we have to understand the earthquake processes before we comment anything about the media. Okay. So you can see here, I published a series of papers, the changes observed in land and ocean after Gujarat earthquake, precursory signals using satellite and ground data associated with the Ventura earthquake, multi-sensory studies of the Sumatra earthquake and tsunami of 26 December 2004. This is in the International Journal of Remote Sensing. And then we took this surface latent heat flux. We try to do wavelet anomaly to identify the real signals. Okay. So same thing. People, the Japanese people, they contacted me, and this Guido Cervano, he is a professor now at Penn State. He did a PhD with me, and we combined the different anomalies. Okay, so you can see here thermal, atmospheric, ionospheric anomalies around the time of the Colima magnitude 7.8 earthquake of 21st January 2003. And there also we combine the surface latent heat flux anomaly and the OLR anomaly. Okay, and the ionospheric anomaly. Okay, so here is the Denali earthquake. We published this paper. We try to see all the meteorological parameters, okay, and also the surface latent heat flux. We saw the anomaly, okay. And then we took Haiti earthquake, and Haiti earthquake, when I did analysis for the 12th January 2010, I combined with the surface data and atmospheric parameters. So we found some anomalies. Okay, whether that anomaly is really is reliable or not, I will not say that. Okay, so here in Haiti, such anomaly we found prior to the earthquake, but if you see the total ozone column, it gives such trend. Okay, after the earthquake, the signal increases. So such an increase we found in so many earthquakes. Okay, so we noticed this one, and we try to analyze about the Wenchun earthquake in China, and we saw the anomaly, the temperature anomaly, the surface skin temperature, and also the surface latent heat flux, and you can see the relative humidity. Okay, so then this is the image of the radon. Okay, I was listening Dr. Walter Moni's talk. People, they were asking about the anomaly, seismoelectromagnetic anomaly, and also radon. I will tell you this. And in the Kobe earthquake, they found the anomaly, and this is what I'm trying to show you. So what I'm trying to say that the integrated efforts are needed to identify reliable earthquake precursor and understand earthquake processes. And I must congratulate Dr. Barua, senior scientist of NEST, that he is handling the multi-parameter observatory, and which is the need of the day. Okay, and such multi-parameter studies are also being done in China. So China is the only country. In India, you have one or two observatories, but China, they are trying to monitor so many parameters, and in China, large network is sponsored by China Earthquake Administration. Okay, so I'm going to tell you this. This is a distribution of the China Earthquake Precursor Network. 778 China precursor stations are there. And then this is about the crustal deformation network, okay, in China. This is the geomagnetic network, geoelectrical geomagnetic network. China is making a lot of efforts. You can see not only this, the borehole, underground fluid network of China. You can see so many boreholes. Whether we have, okay, the question is this, we don't have. So here there was two earthquakes occurred, the Wenchun and Luzon. And Wenchun earthquake occurred in 2008, Luzon earthquake occurred in 2013. And you can see the location of this along the fault, and they have observatory, and they measure the radon. Okay, and the radon measurement was done in India by Dr. Sukija from NGRI, Dr. Virk from Guru Nanak Dev University. Okay, and I do not want to encourage any people. Okay, because I along with the Chinese students, we carried out the analysis of the 20 years of the radon, water level, water temperature data. So here what you see, this is one observatory. Wenchun earthquake occurred at this point. Luzon earthquake occurred here. Wenchun earthquake occurred when the radon level was increasing. Luzon earthquake occurred when the radon level was decreasing. No trend. Okay, and so that is a very difficult. We published this paper. The characteristic behavior of water radon associated with the Wenchun and Luzon earthquake along Longmen-Shan fault. And here I carried out a lot of analysis of the rainfall data, and then I concluded that we did not find any pattern. The Chinese, this student, when this paper was published, she did not tell her boss that we did the find like this. Otherwise, the boss is going to ban her that, hey, we believe that the earthquake occurred, but we did not find any pattern. You can read this paper, okay? So we should be careful about such an anomaly, okay? So here, I saw this paper today, Geochemical Journal, 2011, by possible link between radon anomaly and earthquake. And you can see such data were published by Lusker and other people there. This is not a very high impact journal, 1.1 or 0.9. Okay, so such a thing, because these days, if you get some data, you try to publish this. Okay, we should try to publish a good paper. Okay, so hydrological response associated with earthquakes. Let me go ahead. I'm trying to show you some of the papers, and we found the co-seismic. Okay, co-seismic related with the Gorkha Nepal earthquake, and also Wenchun earthquake, Tohoku Oki earthquake, and here is the Wenchun earthquake. And we published, these are the good journals, Tectonics, the Pure and Applied Geophysics, you see. And where we are measuring, this data is being measured in China. China, there have so many boreholes, so they find the anomaly at a far distances. Okay, far distances. So groundwater level response to the Wenchun earthquake. And now you can see, I want to tell you, this was the 26th August 2000. I came from Japan, I believe, at that time, and there was a heavy rainfall occurring in Hyderabad. And I issued a press release. You can see my name, and it came in the newspaper with the PTI, and the heavy rains and floods in Andhra Pradesh may cause earthquakes. Okay, so this was noted by one of the MLA in the Hyderabad Assembly. And you will be surprised, this earthquake occurred, and there was a news on 17th September 2000. See this date? And even if you Google, you will find my name there. Okay. And then people from IIT Kanpur, they asked me, oh, did you predict this? I said, no, I did not predict that. Okay. And then this guy, who was a member of the assembly, MLA, he raised this question in Andhra Pradesh Assembly. And the NGI, Dr. Gupta was the director. At that time, he sent B.K. Rastogi to defend them. And there was an earthquake in Banjara Hill. Okay. So the question is, why such prediction I did? Because the Hyderabad is in a granitic environment. And when there is a lot of like a rainfall, And of course, the water has a very strong flow. Okay, when in the strong flow, when the water is percolating, it can create a triggering. It can trigger the earthquake. Okay, so this is what happens. So here I want to show you that we in China we are trying to measure the earthquake. Okay, we try to find a relation with the water level. You can see the amplitude, epicentral distance. Okay, and we found some anomaly. And here the La Habra earthquake of 5.1, and the beauty of in US, there are a network, dense network of the borehole. They measure the water level in the whole of the United States. And you can see the borehole earthquakes. We try to analyze this, and we found some co-seismic anomaly. Okay, and always there was the earthquake in Virginia, and in 2011, I tried to analyze the earthquake from the 7th station. We found the co-seismic anomaly. You see, and so the co-seismic anomaly, you can see the station 3, the co-seismic anomaly. So the water level, I found the water level, the interval of 15 minutes. You see, so one should try to see that one. And I would like that we should have such a type of borehole. So Gorkha Nepal earthquake, and I'm going to close this very soon. And you can see again for the Gorkha earthquake, and my colleague, Chinese colleague, they found the anomalies, the co-seismic anomaly, the change in the water level, change in the temperature. Okay, this water, this Jingle Well is about 3,000 kilometers far away from the epicenter. They found the anomaly. Okay, so co-seismic response of water level in Jingle Well about the Gorkha Nepal earthquake. You can see the P wave, just like a water level, also act as a seismographs. So you can see the P waves, the S waves, and surface waves. It is matching very well, and these are the provides a precursor signals. And this is for the Ventune earthquake. You can see, you can read this paper. We found the co-seismic anomaly with the water level and water temperature. Okay, and this is again co-seismic signal we found. So I want to show you that there were so many earthquakes we considered. And the red and the blue one, 75 earthquakes around the globe, red dots showing co-seismic response measured in China. Blue dots, no co-seismic response. Okay, so you will not be surprised whether you are getting co-seismic at some time, not at the other time, because of the so many factors, the tectonic environment, geological environment, hydrological environment is quite different. This paper I saw, I put the name here, which is published by Israeli people, and they found the water vapor pressure with the time at the observed at a different location. Okay, I want to show you this one. I don't have that video. One time I was in Hawaii when the tidal wave is coming, 500 meters far away from the coastal areas, you can see the bubble. Okay, so the water level is going to give you a good signal. Oh, yes. See this? This is the thing one can see. Okay, so many groups are involved in measuring different type of gases. What is the physics? The physics is the earthquake, crustal distress, ground shaking, and as a result, you get a stream flow, well levels, the pore pressure change, and then gas emission you emitted. In some earthquake, not always you get the gas emission. Okay, so and I'm going to skip this one. This is our latest paper on the passive microwave remote sensing about the earthquake. And there, again, we found the carbon monoxide mixing ratio. You can see the anomaly at a different pressure level for the Nepal earthquake. And this is again the special distribution of temperature. And here the same thing, carbon monoxide. Okay, and here is the surface air temperature. And this I'm trying to show you different pressure levels prior to the Nepal earthquake. Okay, so this is the total column ozone. I'm trying to work on this total ozone column, and the total ozone column, the ozone home is in the stratosphere. And we are getting an ionospheric anomaly. It could be related with the air temperature. It could be related with the total column ozone. And this guy, they published a very good papers in AIP, the Applied Physics Letter, which is considered as a good journal. And I'm trying to relate with this, why we are getting ozone anomaly. Okay, so they try to measure the different rocks, and they find the ozone concentration. So it's really important to look into total ozone column as a precursor and combine with the ionospheric signal. Okay, so here, this paper, I read that one today, and I believe some of the co-authors from your institute, and then the remote sensing person is the PLN Raju, director of the remote sensing center team in Assam. Okay, and this is they try to consider soil radon and geomagnetic anomaly and total electron content. Such efforts we should do. Otherwise, I will discourage people who are trying to work in the precursor. If you find so many multi-parameters, I will encourage them. But if you find only one parameter, and if you are trying to understand this, I will totally discourage you. India has spent a lot of money, and they have put also borehole in the Koina, okay, and where we are going. But at the same time, I would like to say that there is another paper, very good paper, Reema Chatterjee, I think Kayal's, he's very familiar with her. Estimation of pore pressure, tectonic strain, stress magnitude in the upper Assam basin. Such work is very much needed and is very much important. And so the question is, can we use existing oil wells in Assam and deploy instruments to monitor earthquake? And Dr. Barua and director of this institute should try to this. And the blowout, what is going on, and that is because of the water level fluctuation inside at the depth. And this is why I told Barua that they collect some data, and then you can try to understand this. Okay, so that is very, very important. Okay, so here we should also see the GPS station in the United States, and this is the GPS station in California. Okay, do we have such a GPS network in India, in Assam? We need such a GPS station. Okay, we are spending so much money. Okay, but such a GPS is a multi-faceted parameters it can provide, and you can use understand the the stress regime. You can get information about the water vapor. You can get the information about the storms. Okay, and you should try to have the dense network of GPS in Assam. Okay, so what we need an integrated approach. We need an integrated approach of remote sensing, GIS, GPS, LiDAR, airborne, to understand the dynamic nature of the earthquake in the Himalaya and elsewhere. Okay, my conclusion. Integrated approach is needed to understand the hydrological, surface, atmosphere, and meteorological response associated with the earthquake. Earthquakes are complex in nature. Complexity varies from location to location and earthquake to earthquake. Long-term data of various parameters observed from ground and satellites are needed to understand the response associated with the earthquake and also for reliable precursor. So I do not want to disappoint my young people. I would like to encourage them that they should follow the integrated approach if they are working in the earthquake forecasting, prediction. Otherwise, right now people are trying to use the P waves, the S waves, based on the P and S waves. They are trying to develop the alert system. So thank you very much.
So thank you very much for your very impressive and attention-grabbing talk on earthquake precursors. Now may I request Professor J.R. Kyle for his remarks. Over to Professor J.R. Kyle.
Okay, thank you, Santanu. I think Professor Singh has elaborated his, lifetime experiences in earthquake precursor studies, and the ground truth has been very much opened by him, and I think young generation should follow his guidance or guidelines that integrated approach should be used for earthquake precursors. I think there will be a lot of queries and questions from the participants, so I will not take much time. So thank you, Professor Singh, for your very elaborating lectures, and over to Santanu now, please.
Thank you, sir. Dr.
Thank you, sir. Now may I request Mr. Prasijya Bodhakur for a question and answer session. Over to Prasijya.
Thank you, sir. The first question is, have you found the case where the foreshock seismicity before the main shock matched well with the other precursor anomaly, such as tech, magnetic, etc.?
Yes, I have written the papers on the integrated approach, okay, where I saw the subsurface, surface, atmosphere, and ionospheric anomaly. Okay, not always you get it.
Okay. The next one is, what will be the vertical and lateral resolution in remote sensing images to know about the fault, if any?
About the fault, yes, you can know very well. The vertical means you are talking about the deeper. You're talking about the deeper.
I think
deeper
so.
You cannot get it. Okay, deeper you cannot get it from the remote sensing. You can get the surface, the image what I told you. Okay, and even if you go on the USGS website and try to play with the recent earthquake data, you can also combine with the fault in California. You can overlap. Okay, so you get a line on the vertical depth, and you get it. Okay. Vertical depth, for that you have to do geophysical survey for that, seismic survey.
Yes, sir.
Right.
Okay, so Dr. Sarosh Kumar Mandal wants to know, can monitoring of radon anomalies help in precursors of earthquake?
Look, I I presented the 2 decades data, and I was very close to the, Dr. Virk. He's my friend. Okay, and also he knows Dr. Sukija and other people. But and you do not get so much about the radon, you see. And I showed the radon peak in the Kobe earthquake, radon peak in somewhere else. Okay, so you might get it if you are don't spend your money. If you find some setup you try to do and try to learn this. Okay, I would not like that the government should pay money to monitor the radon and other things. Okay, so I discouraged that one. And if you are the way you people are doing multi-parameters, that is a good idea to do this. And I know I'm getting a lot of papers to review, and then I said no, unless you combine with the other data, I'm not going to accept that. Okay, so radon, same story. Since the last 50 years, we are seeing this, and you can ask Dr. Carroll, okay, and this is the big problem. That's it.
Okay, sir. So the next question is, what is the transmission mechanism process from earthquake surface to ionosphere to detect an anomaly prior and after to the earthquake?
Yes. Okay. So I told you there are a number of parameters. Okay. I gave a lot of I analyzed about 500, 600 earthquakes. So the question is, on the surface, near the surface, you have a water table, okay, and on the upper surface you have a pore spaces. The pore spaces are filled with the gases. So when there is any disturbance, the water table fluctuate, and when the water table fluctuates, the gases are emitted. Okay, and these gases, the relative humidity changes. Okay, and then so far we have not understood the whole mechanism how this ionospheric anomalies we get it. But there are the papers coming up. This is the gravity waves and other things is coming up. Okay, so we have to wait for that. And right now people are trying to publish their observation in a good journal, so JGR. Okay, space physics, solid physics. Okay, so we have to wait for that. Okay. But whatever the carbon monoxide, I showed that one. This is related with the hydrological environment is very, very important. Whenever there is like stresses are built up, the water table starts fluctuating. When the water table starts fluctuating, there is the emission of the gases which exist near the earth, and then you can see this will modify the meteorological parameters and then ionospheric anomaly. Okay.
Okay, sir. So there is another question from an anonymous. So can you use Sentinel-1 data to measure surface deformation of an earthquake? If yes, how is the accuracy of this data?
Yes, the Sentinel data is very good. Okay, and I will encourage people to use it. Okay, and even this Sentinel data, we try to analyze this for the blowout. Okay, and the blowout is very important. You can study about the carbon monoxide, the methane gas, and other things. Okay, so the resolution wise is also very good. Okay.
Yes, sir. Dipjyoti Goswami wants to know, do you see any change in the atmosphere during the time of stress accumulation in the intraplate region, as you know a little about the intraplate tectonic processes due to lack of seismic events?
Look, in the intraplate, if you consider Gujarat the intraplate, and I presented for the Gujarat, I have not seen other earthquakes. Now I try to analyze for Palghar. Okay, Palghar, Vineet Galot and other people, they are working and they have published papers about that. Okay, so in the intraplate, I don't think I have I found any anomaly. Okay, why is that? Because the water is not near the surface. Okay, like I was trying to look for the surface latent heat flux anomaly and other things, so I did not find. But the intraplate earthquake, I have published one or two papers related with that, and what I find whenever we find the fluid present in the lower crustal region or the mid crustal, so there you are getting earthquake. Okay, because the inner plate is moving at the rate of 4 to 5 centimeters per year, and if it is a fluid, there is the triggering of the earthquake. Okay, so one of my students, he produced a PhD thesis, and I wrote a paper on the Latur earthquake, and there we are talking about this. Okay.
Sabine Tiwari wants to know, in what time interval after the prediction of an earthquake precursor, earthquake is supposed to happen? Is the earthquake precursor similar to microtremor investigation?
Yes. Look here, the question is, the people are trying to show from one day to few months. I don't believe that. Okay, if you do not find it within 1 day, 2 days, 3 days, then it becomes simple. People like it, they are getting some relation, but I really think I will not believe that one. If it is 1 day, 2 days, like the way I showed it, then I can understand that. So why? Because the earthquake environment is different, the geology is different, tectonics is different, so you will not find it. And the focal depth is different, right? So it becomes very, very difficult.
I think that's all.
Okay.
Thank you very much, sir, for your question and answer session. Okay. Once again, I thank you for kindly accepting our request for delivering this talk. May I request Mr. Prasidjo to go for his vote of thanks. Over to Mr. Prasidjo.
Thank you, Dr. Santanu, sir. Good morning, respected dignitaries. I, Prasidjo Borthakur, on behalf of CSIR NIST and the entire organizing committee of IVWGST 2020, convey my sincere thanks to Professor Ramesh Singh, sir, for such an informative and descriptive talk and giving us a deep insight about the earthquake precursor. It was a great honor to have you with us, sir, today. Your lecture has showered tremendous knowledge upon us. Once again, thank you for your valuable time and enlightening us with such an amazing talk. Thank you, sir.
Thank you very much, okay, Dr. Barua and the other people. Okay, so thanks a lot. If you have any questions, you write to me and I will be there. Okay.
Yes.
Thank you, Gautam. Okay. And at what, Dr. Gale, thank you very much. What time is Dr. Susan's talk tomorrow?
In the morning. In the morning.
Oh,
In the morning.
in your evening, right?
Yeah.
7 o'clock.
In my
Okay.
morning. In my morning. Yeah. Yeah.
Okay, Dr. Barua, I would like to discuss with you. Send me your phone number and other thing, multi-parameters, and then we can go ahead. Okay?
Thank you, sir. Thank you so much. Thank you.
Okay,
Nice
thanks
to
a
hear
lot.
you.
Okay.
Thank you,
Thank
Professor
you.
Kal. Thank
Okay.
you, Dr.
Thank you.
Singh. Thank
Okay.
you, Chapman.
Okay.